today I would like to make a 3D version of Frost Solver, and I am going to be making the solver based on the 2D solver, 2D Frost Solver, which has been made by Anton Grabowski, and he's already explaining how to make this kind of Frost solver plus animations done in Houdini. So I am mostly gonna be I'm mostly gonna refer to his work and modify it a bit of his work to implement it for 3D frosting. So let me try to explain that, how I can do that. Okay. First of all, let's make a base geometry for the frosting. For the Anton's examples, it was made on top of grid, but for this example, I would like to make on a sphere, so that if you change the sphere to any kinds of 3D geometry, it could be reused for 3D frosting. So as a typical shape, let's use sphere as a template. And I'm gonna set the frequency to 10 to make it smooth enough. And let's set this to, let's name this base geo. Alright. Now first thing I would want to do is to create a point on top of the sphere, which will be a starting point of the frost. And I guess I should explain it in Sketch. Okay, so it basically works like this. First of all, you have the base points, which starts the frosting like this. Now the things that I would like to do is to, let's delete this altogether and set the base point first, and from those base point you also set the starting point, like could be randomly, and from the first frame the frost solver will start making the frost from this starting point to the horizontal direction on the surface directions. And by the time it comes near to the other base points, then this will become the starting points as well, and making the frosting as well. And if the frost goes by here, and when it comes close enough, it will become starting point. This will become starting point. This will become starting point, and then we'll do the same growth. Now that's the base. That's the basic. Now, in order to define how the frost should move, should grow, if you think about how each frost works, basically it's a hexagonal directions, hexagonal growth. So basically the growth will go by 60 degrees on a surface, each 60 degrees, which would make a 360 degrees, and which have 6 sides. And frost could go any of each direction, like this. Depending on the conditions on the surface, like temperatures, humidity, are there any other conditions? Sometimes the branch itself would not born. Sometimes it's just 4 branches, sometimes it could be just 2 branches, sometimes it could be 6 branches. So we can control that due to the condition of the surface, or in this case could be random as well. And the flow of the growth, it might without any conditions on the surface, it would just go straight to 60 degrees, but it's not really realistic, and somehow it would carve like this, or like this, or like this, or sometimes it would just stop at some lengths. So in order to make this kind of conditions, what Anton explaining in his tutorial is to make a gravity field as well, besides the base points, like this kind of gravity field, which mostly goes from the starting point to outside, but somehow it have some rotation curve, rotation vectors randomly, or maybe using some noise function, and not really drastically, but somehow it will enable the vectors which would try to go to straight to 60 degrees directions to angle it a little bit using those gravity field or vector field. So that's the first thing I would like to implement inside Houdini. Okay, so first thing first, let's make a base points using a scatter, and on top of the surface, on top of the sphere surface. This might be too much. Let me make a null to gather all the parameters I would like to control later. And let's color it blue. Okay, and let's go to a edit parameter interface, and let's make a first parameter here, which will be a number of point, so source point, I guess. So source pt num, and range I would set from 0 to 100. Apply. Okay, let's make another one. For this one, let's make a number of points for the vector field, the base points of the vector field. So I will just call it ref pt num, and this could be really high, so like 10,000 or 100,000. Okay, let's go with this. And for the source PT num, I would like set something like 70 maybe for now. Copy this and paste it here. Okay, let's also set the radius of the sphere, which I would like to control here. So let's make a float. Name this radius. Right, and yeah, it could be from 0 to 10. Let's set it to something like 5 and copy parameter, paste it to the uniform scales. Okay, good. Now, after making the points, I would like to set some of the points in for these base points to be a starting point, which would start making the frost from the first frame. So let's make a point wrangle to make a conditions. Okay, let's make a parameter here, float, threshold, CHF threshold. Also a random seed. Let's get this here. And if the rand at ptnum plus seed is less than threshold, then make the set the attribute start to be 1. Or wait, am I missing something? If rand seed. Okay, maybe I could just set the group to be 1. So set point group start to be 1. Okay, I think, oh yeah, I have to set the number of point here. Okay, let's check that out in the geometry spreadsheet. And do I see anything? Nope, because this is set to 0. Threshold, okay. So if I set the threshold to something like this, so 30% of T points will become the starting point. Well, that will be too much. Maybe I'll just go with the 10% now, and the seed will change the position of the starting point. Okay. Okay, let's also set these to the parameters, since those are pretty important. Just let's make 2. One is the source point threshold, source point threshold, and this could be from 0 to 1 because the random is from 0 to 1. And also the random seed, source pt seed, source pt seed. This could be any kind of ranges, so I'll just set to 0 to 10. And I'll just set some random number here. Let's just set 0.1 here. For the ref point, I'll just set some random number here as well. Okay, and let's copy this, paste it here. Also copy this random seed and paste it here. Alright. And I'll name this start points. Okay. Now let's also make the reference points, which will work as a vector field in order to define the direction how the frost should grow. Okay, let's do that. Okay, so let's do the another scattering. Connect it here. Now this points could be really high number like this because it's just a reference, and you want to know really like detail point position points, all detailed dense informations for the vector field. So maybe this amount is okay, maybe too much. I'll just reduce this to 50,000. Okay. And also I'm just gonna turn off the relax iterations. Or maybe not. Maybe not. Or maybe I would want some random behaviors for each point, so maybe I'll just go with this. Okay. Also, I would like to give each point a normal direction. Right now it doesn't have any. As a normal directions, I would like to set the normal direction based on this surface. So the easiest way I could think of is to use array and connect the first points to the first input, and then the collision to the second, and also turn on the point intersection normal, which will give you which should give you the normal points, I thought. Let's check geometry. Yeah. No, it doesn't have any. Okay. Doesn't seem to have a point intersections. Okay, I have to set it the method to minimum distance. Okay, now I have all the points with the normal directions. It's good. Let's turn this off. And next thing I would like to do is to make a actual vector field from this point, from this collection of points, together with the starting points, since I would want the vector field to be generated from the center of each starting point, which will run over the surface 360 degrees. And so in the end, it should give you something more like a Voronoi diagram with the vector field. So let's try to make that. Let's make a point wrangle first to modify the points for this points with the normal directions, and as a reference set the starting points to the second input. Let's write some code here. Okay, let's set the first parameter, float smoothness, chf. This is for the noise function, and float max angle. This is for how much it should the vector field should rotate using the normal axis to make us use the noise function to create an angle and use an angle to rotate the vector field, which comes straight at first. But if it's straight, it's not really natural, so I gotta use some random functions to make it a little bit more natural. Okay, and let's get the near point. Now from the second input, using the point position, the current point position, I will get the closest starting point, information starting point number using this, or base point number. And then from that, I could make a vector and pass equals to point from second input and make a direction. This direction will actually be a vector field, the base for the vector field, and I'll just normalize this from the current position, from the starting point to the current position. Now let's test that out to see how it looks like right now without using the noise function. Okay, to the direction attributes, direction vector attributes, I'm just gonna set the direction here that I have just made, and let's see how it looks like. Let's make a marker here, and I'll name this there as a direction, and not the text but vector. It's a bit too big. Okay, so it looks like this. Each point have its direction from the starting points to outward, like for 360 degrees. And if you look far from, if you look at from far away, it does make a Voronoi cell looking pattern like this. But right now it's, as you can see, the vector itself is pretty too much straight up, and if you use this for the frost generations, the frost will become pretty much straight as well, which will be looking pretty much artificial. So let's make a noise function to randomize this flow vector fields a bit. Okay. Let's, in between here, let's make an angle and use the A noise. It's the aggregator noise, and based on the point plus the smoothness, multiply by max angle. And this is indeed written in degrees, so let's convert it into radians. Okay, and let's make the vector for rot quaternion for the rotation, with the angle and the axis. The axis will be the normal direction, since I'm just wanna rotate this vector field like a typhoon based on the n-axis, a normal axis. Now the new direction will be q rotate rot dill, and let's normalize this again here to see how it looks like. Now I have to promote the parameters here. Now let's try to move this a little bit. Okay. Doesn't change a bit because the max angle is a bit too small because this is set. This has to be degrees, set in degrees. So let's go to the parameter settings and set the maximum range to 180 degrees. Now if I change this, now I starting to see some changes here, I think. Yeah, with the smoothness and the angle, I do see some changes. So it's not that drastic, but you can see some changes on a few changes on how it curves, how it rotates, how the vector field transformed based on the noise function. And I'll just go with 90 degrees maximum and smoothness of, I don't know, maybe 0.3 or something. Could be any. The intention here is to make somehow a bit randomize this vector field. Okay, I guess I'm not gonna promote these parameters to the controller here because this is kind of a minor setup. So let's continue. And next thing I would like to do is to right now I only have the direction vector inside this reference vector and I don't have those direction vector for the starting point. So what I want to do is to refer to the reference vector field to set the base direction vector to the starting point. Now for that one I can use the transfer attribute transfer, okay, and connect it here. And what I would like to transfer is, oops, don't need this. What I want to transfer is the points attributes. One is direction, and I could also promote transfer a normal normal direction as well. So let's look at that. So first, the direction vector has been successfully transferred, and also the normal direction has also been transferred as well. Okay, now let's go to the next one. Before doing the calculation as a solver, let's set the initial conditions for the points using the point wrangle. Let's name this vector field. Okay, and for the initial points, I'll just name this init point. And first of all of these points are the base points. Oops. All of these points should be the base points. So I will set the group to say that these points are included in the base group. So set point group base ptnum to 1. Okay, and also and later on the base group, those points will lose the attribute. Those groups will lose the group base, but I also still want to keep the initial condition of the points, like which one is how, when, where did the frost initially started. So even after all the frost growth, I still would like to know the initial point position, point number of the frost branch. So for that one, I'm also setting another group called source at ptnum with 1, and also let's set a point group if the point is on the end of the frost branch. I'll call it end. Now for the initial numbers, I'll set to 0. Initial conditions I'll set to 0 because I would like to start from it. I don't want to end from the initial point. Now let's see if I'm getting it. So I have the group base, group end, group source, and group start. Okay, anything else? Yeah. Let's also set whether the point have a branch. So basically the frost branch should be looking like this. Let's say this is the starting point, and the main branch, the main growth will go like this for this will be around 60 degrees, and sometimes you don't have those randomly, but let's say this is the main growth branch, and from this main branch you'll have another sub branch like a leaf on top of this curve. Like for each divided point you'll have this kind of leaf-like branches. And whether I will set the group whether if these points have those sub-branch or not, and I will name it as fork. So if the fork is 1, then the points have this sub-branch. If the point doesn't have any sub-branch, then the fork equals to 0. So that's the group. What I'm gonna set right now, set point group fork pt num 0. Right now you don't have any sub-branch for initial points, so it will be 0. And let's also set a group for the fork end, which means the end point of the sub-branch. And right now I don't even have any sub-branch, so this is also will be set to 0. And finally, as an attribute, let's set the length of each point. Now, what does length mean for each point? Means is that for each point, like here, if this is the point I'm looking at right now, then the length will be this length. If this is so for this point you will have this length. If this is the point position, then the length will be like this. And if it's the last point, then you'll have all the branch lengths. And same as for the sub branches, if this is the point, then this should be the length for this point. If this is the point here, then the length will be from the starting point of the sub branch to the point position. Now that's the point length that I'm gonna use here. Okay. Now that's for the initializing the points. I also need to initialize the primitives. Well, I don't really have any primitives right now at this point because there's only points and there's no primitives, as you can see, but I can still set the initial attributes and groups. So let's do that. Okay, primitive wrangle. And I'll name this init prims. Now, the first thing is the first thing I would like to do is the give is the generation integer value, which will be used if it's the main branch, that's starting from the starting point. I mean this branch, this big branch, then the generation will be 0. If it's the sub branch, then the generation will be 1. Okay, and also a side. Side will be defined whether it's on the left side or on the right side. If it's on the left side, it's 0. If it's on the right side, it's 1. And parent. Parent is the point number of, or the primitive number of the parent of this sub branch, or the so if you're looking at this primitive, then the parent primitive will be this main branch. So that's how parent should work. So I'll just set to 0 for initial number. Then also set the color for the primitive. Right now I'll just go with white. Okay. Now that's enough for the initial attributes. Let's put this into the null. And I'll name this source pt. And I also would like to make another null. Oops. Copy paste this one and connect it to the vector field. And I'll name this as ref point. Okay. And finally, let's bring this base geometry, this sphere geometry, down to here and start doing the frost calculation using the solver, which will be the main point of this tutorial. Okay, so make a solver, connect the source point to the first input and the ref point to the second input, and the base geometry to the third input. And let's get inside. Okay. Now, first thing first, I would like to make a initial branch, like from each starting point. First of all, what I need to do is to get the starting point, just the starting point, in order to start. But before doing that, let's check out if the starting points are being reduced by the initial condition up here. So let's use the delete to set the condition here. Wait, what kind of, okay, so I have the start. Now nothing seems okay. I have to set the points and delete non-selected, and I do have some 0 points which will be the starting point, and that's good. Okay, I just wanted to check that. Now I'll delete this and make another delete component. And the first thing what I would like to do is to go to a points and set it to delete selected, and I would like to I would like to wait a minute. Delete the points which is on the base, which has the base group here. And let's also make a point wrangle here. And connect the pref frame to the first input and deleted points to the second one. And then let's search for the nearest point on each starting point, or the base point. Yeah, I'll just set it to base here. So basically I'm all looking at the base points right now, and then I'm excluding the points which have the base group. Right now this is all base, so this doesn't really make any sense, but later on there will be points which is not included in the base points, and for that one what I'm trying to do here is to convert the base point depending on the radius of the closest nearest other point. Okay, let me make a sketch for what I'm trying to say. Okay. Now say this is the base point, and this is the other points right here. And right now, let's say the starting point is only here, right? And when from the base points, it will make a search around its position like this, like this, like this. And if the base points, from the base points, if it finds a point which is not included in the base, in this case it's the points on the red, colored red, like this, then the base point will become the starting point. But if the base point couldn't find the red point, which will be the point that's not included in the base group, then the base group stays as it is and will wait until the red point comes close enough to make this be to convert this into the starting point. So that's what I'm trying to do here. So I'll make a handle PC open. I'm looking at the second input with the P with the current position, and let's also make a variable, the parameter, the search radius. And if the PC iterate handle, since this will be only 1 point, this will be only 1 point, maximum 1 points, I will just do 1 iterations, then set the start group of the current point, set point group start to be 1. Okay, and I'll name this set start. So this is the conditional script which will convert the base group to the start group in order to start generating the frost. Okay. Alright, then actually use that start group to create initial main branches for each starting point. Now I'll set the filter to start and run over the points. Okay. Now let me write some scripts, and this is pretty much based on the Anton Grabowski already wrote. So I'll just go pretty quick and just trying to explain what it's doing. First of all, let's make an increment variable which starts from 0 and make a while loop inc till 6. This is 6 because I would like to rotate the angle of the branches 60 degrees. So 60 degrees by 6 is 360 degrees. So that's why it's 6. And increment the inc variable by 1 at the end. Okay. Now the first thing I would like to do is I don't want just all the starting point to have 6 branches, but I would like to have random number of branches for each starting point. So make a condition here first. If random ptnum plus incremented number, and plus maybe I could add a seed value. So let's make a float seed, chf seed, and add the seed here. This will give me the random number from 0 to 1, and then make a condition. Okay, let's make another parameter here. float variance equals CHF variance and if so, then increment the inc variable and then continue, which will skip all the rest of the calculations that I'm gonna write next, because I'm adding because I'm adding 1 to inc variable and it only runs 6 times, but I'm skipping 1 here. So if this matches 50% of times by running 6, when it runs 6 times, then it will only run 3 times for the later calculation. Okay, the next thing I would like to do is to first make a base angle, which is the radians, the multiplication of the 60 degrees. And also let's get the rotation axis, which will be normal vector in this case. Okay, and let's make a matrix rot for the rotation. Well, let's make a matrix. Let's convert the rotation matrix using the rotate, using the angle and the axis. Okay, so the basic direction of the point will be v art there. Each point already have this variable. So what I want to do here is that make a new direction by rotating this original direction vector by rot, the rot matrix, rotation matrix. Now let's also set how much it should move for each branches, how much it should move for each frames as a branch. Let's make a variable called step. And here I'm making a step vector, which will be the current position plus the direction, modified direction, times step number. This one. Apply. I don't have an error right now, so I'll just continue. Now let's search for the points with the specific radius here, or maybe I could just use a new point, which might be simple, since I only need one reference. So I'll make a npt near point with the moved point, which will be this one. This will be the new position of the point, okay? Which will, because it's being moved with the step value with the direction, and I'm searching the second input of this one, which should come from here. The second input is the reference point, which have all the vector fields, and I'm referring to it using this new point. And by the step back position, which is the new position, and then I guess that's it, and I'm just searching for the nearest point, and then from that near point I could get a attributes from the points of the from reference points. What I would like to get is the direction vector on this new point position. So vector and NDL and direction, so it's the neighbor directions, and near direction I guess is a point from the second input, name direction at npt. Okay, so now I've got the new direction for the new points. This is the new points. What I want to do next is to create, since this is the initial branch creation, I would like to make a primitive to be a polyline. And from now on, when the branch grows, the vertices will be added to this primitive. And the first point of the primitive will be the current position, obviously. And the second point position will be the... Right now I don't have any points right now, so add point at step vec position. Okay. Now also let's add a vertex to the primitive with the pt0 and pt1. And let's set some parameters, the attributes to this primitive. First of all, set prim attriv type. The type will be used whether if it's the main branch or the sub branch, type A, type B, type C, or type something, and I'm gonna set as an integer. So the initial branch type will be the main branch, which starts from the starting point. So I'll just set to 0, and 0 will be the main branch. Okay, and also let's also set the set point group name end, because the pt1 will be the last point, so I'll set the end to 1 and set point group n to this is not group, this is attribute. N to pt0 to be at mark n, and also set the point attriv 0 direction of the pt0 to be direction, and for the set point attriv 0 and pt1, this could be at mark n, but if you want to make it more precise, I could add another near normal here. I'll just say n nom point 1 n npt, and I can set n norm here. And lastly, set point attrib direction for the last point, be n direction. Right. Apply. There's no error. And last of all, after all the iterations 6 times, I would like to set the base to be 0. Since this has been converted into the the branches, I'm not going to use it for starting point anymore, which means I also need to set the start group to 0 as well. Set point group. Right. Okay. Apply, and let's see how it goes. Oh, I also have to promote some parameter here. Now seed could be any numbers, variance could be like 0.3 or yeah, 0.3 is okay. This will means that 30% of the 6 iterates will be used. So 30%, so probably 2 or 3 branches will be created if it's through 3. I'll just go with 4 then, 40%. And the step is the length of each starting initial branch. So let's say something like 0.1 or 0.15, and let's see how it looks like. And there you see those initial branches. For this one you have 3 branches, this one have only 1 branches, this one have 4 branches. And if you increase the step, you will have longer branches, longer initial branches. If you have increased the variance, then okay, you have less branches. If you lower the variance, you'll have more chance to create a branch. So I guess what I was saying was wrong for the variance. If lower it is, you have more chance to have more full 6 branches. So I'll just go with 0.5 then, just for 50%. So you basically have a chance to have 3 branches for most of the time, but right now it's 2 or 3. And I could also change the seed here to control the initial conditions. Now for those parameters, I think I can promote it into this controller, since I think I would like to control these as well here. So let's do that. The first thing, variance, branch variance goes from 0 to 1. Another float, step value, step length, which will be 0 to 1 as well. Could be larger or could be less. And also the seed, so I'll say branch seed. Let's name this branch step as well, so that I could easily see what kind of step I want here. Right, and the branch seed could be from 0 to 10, could be any number, okay. And let's set it so the variance I want it to be 0.5 or something. Branch step could be like 0.1 something, and the branch seed random. Copy this and go to the solver and paste it on here. And I'll just copy this to the seed as well and change the name here, branch seed. Also for the step, change this to step. Okay, and let's see if it changes by those parameters. So the branch variance, if I lower the value, I have more chance to have 6 branches. If I increase it, I have less chances to have full branches. If I change the seed, I have random branch conditions, and also for the branch step, I could change the length of the branch step. Cool. Alright, this is okay. This is pretty much fine. Now let's continue inside a solver. Now I have those initial condition, initial branch start. I'll name it branch start. Next thing I would like to do is to create a solver definitions in order to grow these small branch. So based on the vector field on the reference points. Okay, let's do that. Okay, so first thing first, let's make a point wrangle. Oops. Point wrangle. And okay, I'm just gonna group this in order to organize a little bit and connect the branch start to the new point wrangle, and this will be the base growth. Now since what I want to do now is to create a new branch on top of the endpoint of each main branch. So if you look carefully at the branch start, I have set the second points created as an initial branch to be included in the end group. So I am gonna filter using the end here and create some branch growth. Okay, let's do that. Now first, this is also mainly based on the Anton Grabowski's functions. I'm gonna first make a void function called base growth int prim vector step normal and direction. And the new point, which will be point 1, we're gonna add a new point on the step position. Maybe this is not really clear. I'm just gonna name it npos as our next position. And add vertex to the current primitive, which is this one, to PT1. Okay, and set point group end to PT1. Okay, I don't have any errors. And set point attriv the normal from this input, and set point attriv a next direction to end here. Okay. Alright. Now in order to call this functions, first thing I need to do is to search for the obstacles. Since if you're making the branches on the 3D surface, there is a big chance that those branches somehow collide each other at some point. Like if you have those kind of branches from one point and second branches from the second point, somehow at some point this branch will collide with the other branch, and I have to make a condition whether when it's gonna collide, and I have to avoid colliding it in order to make it more natural, or as frosting generations or frost growth would like to stop the growth when it hit with the another branch and just end the growth up until here. Same for the other branch, if it goes until here, and if it find the collision on the forward directions, then the growth should end here. The generation should end here, which will fill the spaces with the generated branches without any crossovers. Let's do that. Okay, so doing an end to the code, let's also first make a variable step, like how far, the step length of the branches, which I used it before, so I could use the same variable inside a controller null parameter. First of all, I have to promote a parameter here in order to link, and a float max length, which will be the maximum length for the branch. Okay. And also float dot threshold, which will be used in order to define the direction of the newly created branch, the last primitive or last point of the branch, last tip of the branch. So this will determine this will be used to define to create a condition for the angles. Okay, now float. Another one I would like to have is the max angle, which will be also used for the angle for the tip of the branch, and to set the position of the tip of the branch. I'll just gonna explain it later, and I'll just gonna promote these for now. And for the step, I could copy the parameter from the controller and So now let's go back to the controller. Copy the, which was it? Step, branch step. Copy this parameter here, and then go back, paste it here. Okay, the maximum lengths I'll just set to 10 as a maximum. I guess I don't need to set the global parameters for this one. The dot slash hold. Okay, I'll just set to 0.8. And for the max angle, I'm just gonna set to 3. So this is being treated as a degrees, and I'm gonna explain how it's gonna be used right now. Okay, so first thing first, I need to set, as I explained previously, I need to make a condition whether the branch will be collided with another branch. So in order to do that, especially for the 3D geometry, the effective way to do that is to first go back to the previous point, which is this one, and then since each point have normal direction like this, so first of all, let's make a point wrangle, and I'll name this block pass, and move this point to the minus direction of the normal direction by 0.5. I mean, it really depends on the size of the sphere. So if the size of the sphere is pretty small, then you should also decrease the value here as well. So I guess I'll just go with the 0.25 right now. So by doing this, I have just moved all those points by 0.25 to the minus direction of the normal direction. And now from here, I'm gonna use the extrude, poly extrude, and gonna extrude using the point normal, existing, or existing's fine, and the distance be the double number of 0.25, so will be 0.5, which will give me something like this. And this plane, the collection of planes, could be used as an obstacle to calculate an intersection. So I'm gonna connect this block geometry to the third input here. Oops. And for the second input, I'm gonna just connect the reference point, which will be this one, which have the vector field, to the second point. Okay. Now it's time to calculate the collision, the intersection. I'm gonna use the ray intersect function here. First of all, let's make a out attribute called allp and alluv, which I don't really not gonna use this. I just need those variable in order to calculate intersect. So intersect from the second input, which I connected to geometry with the current point position plus the moving direction and times some value to determines the movement. I'll just say step times 0.5 and or no, this will be the starting point of the array, so yeah, I guess I cannot. I'll just say 0.1 step times 0.1. Yeah. And the direction plus the distance will be vr at mark direction times step times something like high value like 3. It's fine. I think 2 or 3 is fine, I think. And the alp value, alp and aluv, which I'm not going to use it. Right, so now I have the ray. If the ray is -1, which means the ray couldn't find intersection, which means there's no collision, so I could make a growth on the branches. So this here is where I should write how the branch should grow. Okay. I'm gonna name the new position endPos, which will be at mark P plus the direction on the point, direction attributes on the point, time step, which is how far it should move. And this itself is fine like this, but in order to make it more natural or more randomic, let's add another random value here, which Anton is also doing it in his tutorial. So I'm gonna use a fit 01 rand ptnum to 0.2 to 1.0. So the step value will be shortened randomly by 20% to 100%, in between 20% to 100%. Okay. Which will give you more variance, I guess, to its looks. Now let's search for the near point using a near point to the reference point using the new point position, and I will get the nearest point, 1 point, and from that I could get the next direction, which I did last time using dir at npt. Okay. Now since the primitive, so right now I'm making a branches from the end of the point of the main branch, and since the main branch already has a primitive, so what I would like to do is to refer to that primitive number first, then add a vertices into that primitive to create a long branch, one single primitive with the multiple points. So in order to access the primitive, I could go into prim equals to point prims, and the primitive which included in with this point number, and I think most of the time you only have one primitive, so I'll just get the first primitive number here. Then also let's get the length of the primitive, which I'm gonna apply later on. I'm just gonna read the attributes called length. And let's make a condition here. If, okay, the first condition here is if dot be at mark direction to and the next direction is less than dot threshold dot thresh, then make the next direction to be the current direction. If not, then use the next direction. This means is that it's seeing the angle between the current direction on the points and the next direction. And if the angle is, now this is like from 0 to 1, and if it's 1 close to 1, the angle will be close to 0, which means parallel. This and this is parallel if the results dot is 1. If not, then there is some angles in between these and this and this, and I have set the threshold here, dot threshold. So which means if the angle is bigger than some point, so the 0.5 will be 90 degrees, I think, or 0 will be 90 degrees. Yeah, 0 will be 90 degrees. So if the angle is somehow bigger than this threshold you calculated by dot, then don't use the next point direction, but just use the direction which is on the current point, So use the direction on the current point. If I explain it in the sketches, what I mean is that so this is the okay, so let's say, you have this kind of branches, and from the endpoint of the main branch you want to go to the next branch. Now what you have to do is to define the direction. It's this way, or is this way, or is this way. The thing is that first thing you could do is to from the current position you already have this basic direction vector here, right? So you already know where to go next, which will be around here, using this vector, using this v art mark direction. Okay, so and the length of this step will be step. Now you already have this new position. What you want to apply to this point as an attribute is a new direction for this point, whether to go this way or this way or this way or any way. Now, in order to set the points, in order to set the direction, what you could do is that previously we have made a reference point, which is a vector field, which has tons of points like going this way, going this way, this way, this way, this way, or something like that. So what you could do is that from this point, search for the closest reference point, maybe such as this one. This is the closest, and from those points you can get the direction vector on this reference point, and with this vector and the previous direction vector, you could compare the angle between this and this. So it will be something like this, and eventually you will have a angle value here, and you could get the value using the dot, using the vector 1 and vector 2. And if it's close to 1, this is parallel, which means it's the angle will be 0. But if it's close to 0, then the angle will be will increase more. So if it's 0, I think it's 90 degrees. If it's -1, it's the opposite side. Now, inside the code, I made a condition: if the dot, this value, is less than something like 0.8, then, which means if the angle is bigger than at some point, then just use this one for the new direction. But if it's less than like this angle, or less than 0.8, or the larger than 0.8, I mean less than 0.8, then if less than 0.8, which means if it's bigger than then just use the previous direction. But if it's larger than 0.8, which means it's close to angle 0, then use the vector which is attached on the reference point, which have more curve behaviors like this. But if you use the previous direction, it will just be straight up, since you're using the same direction. So it's better if we could use the reference, the vectors on the reference point. But the problem is that the points from the reference, the vectors on the reference point have at some point have a really opposite direction. Like, say this is the starting point, and as I showed you, the vector field really looks like this. So up until here, the branch could go pretty well using the reference vectors, but from here, if you compare the previous vector with the reference vector, it's obviously the angle is much larger than, like, could be 90 degrees, could be more, which if you just use the reference points vector as a next movement, the point will just go like this. The branches will just go like this, which is pretty jaggy and not really good. So as soon as it met with the reference point, which has more than certain angle, let's just use the previous angle which the original point have, so that it will just go straight up, go straight. Now that's the condition what I would like to make here. And inside the Anton Grabowski's code, he's doing more how do I say, more detailed dense calculations here. So I guess he didn't want it to make it pretty much straight if it couldn't find a reference point. So what he's doing is that he's making another calculations in order to use the previous direction, but somehow randomize the angle to rotate the base angle, so that it won't go too much artificial. But that's too much coding, so I'm just skipping it to make it more simple here. Which means I don't need to use this one, the max angle. And now I have those conditions. Let's make one more condition here with the end. If the length is less than max length, then use these. So I would like to stop the branch at certain point using the max length condition. Now call the base growth function that I have made on top. Finally, with the prim number, end pass, normal vector, and next directions. And finally set point group and at ptnum to be 0, since the point will not be used as an endpoint anymore. Okay, apply, and I don't seem to have any errors, accept. And if I run the program, it should make the branch growth until it collide with the other branch. Let's see it. Okay, now it is running, but as you can see, it has some problem here because it's not running through the surface of the base geometry, in this case sphere. It's just running out of the sphere, running out of the surface, and in that case there's no way it will gonna collide with the other branch. So in order to run on top of the sphere, I need to have the ray here and collide with the base geometry, which is a sphere. I'll name this FPT. I'm doing this base geo and connect it to here and set it to the minimum distance. Let's also calculate the point intersection normal just in case. Right, then let's do the solver animations from the start. Yeah, now it's doing the main branch generations, and as you can see, the branch stops where it met with the other branches. Now that's good. Now thing I noticed is that what I'm expecting more is that when the branch grows like this, I want the other points to become starting point as well when it finds the closest point here. And seems it's not doing it. Something must be wrong inside the code, so let's look at it. And this is where it should do that. I guess this here. Oh yeah, I didn't have the radius parameter here. Okay, let's promote this. Set the parameter to some number like, I don't know, 0.5. And maybe I could promote this to the parameter, but I'll just leave it as it is. I don't want to make it too complex like the one but this is pretty important parameters, so I guess, okay, let's go back to the controller and I will make a new parameter, search rad, search radius, search rad, and let's set the maximum to be 1, and I'll set the 0.5 initially and copy this parameter and paste it here. Paste relative reference, right. Now let's go back on top and see how it goes by playing. If I play it, you can see that when the branch grows, and if the tip of the branch get close to the other starting point like this, the starting point will be activated as a next frost start the branch. This branch will activate the other point as well, like this one, and the branch is blocked by the other branches, and right now it seems pretty well at this point. Yeah, now this is good for the main branch. What I want to do next is the sub branch, and that will be the main part. Okay, at this point I'm speaking like 2 hours, but the original tutorial made by Anton Grabowski is like 6 hours in total, so I'm pretty much shortcutting some stuff. I'm not really doing the detail here. I'm just briefly trying to get the idea of his algorithm to implement it for the 3D. Okay, now let's group this as well. Right, so the next thing I would like to do is to, at this point, let's set the lengths for each point, as I told you before. So for each point, I would like to set an attributes called length, and but the point itself doesn't have a length attributes. What I mean by length is that from the base point, the starting point, to some, if you're looking at the current point, like from here, the length will be from the current point to the starting point, the length of the right here, and same for other points. So let's do that. Okay. For that I'm gonna do the primitive wrangle And for all primitives, first thing I would like to get every points, every vertices, I guess. Prim vertex count. And let's set the initial float, initial length to be 0, and I'm gonna look through all the points, but from the opposite side, so which means from int I equals to npts -1 to 0, like this, because as I said, I have to combine all these lengths in between points if you look from the end. If you look from the start, you just need like several lengths in between points. Alright, and if the I is npts -1, I'm doing this because I'm gonna have to get 2 points in order to calculate the distance in between the points. So the first one, the current point, will be vertex point vertex index prim num at I, and the previous point, it will be vertex point 0 vertex index 0 prim num I plus 1. This is important. Okay, now I have the point a number. I can get the position for both current point and current previous point. So the current position will be 0.0 p at the current point, and the prev position will be 0.0 p prev pt. Right. And the lengths, I'm just gonna increment the length with the distance on between the points, like this. Right. Now I guess that's all about it. Now I have now after calculated the lengths, what I want to do is to set the point attribute, set point attrib call lengths to the current point position with the lengths. Right. So how's that? Okay, so okay, in terms of the lengths, what I was explaining was a bit wrong. Now I realize it's a bit wrong, because by using this, the higher point, the tip of the point, as far as go as far it gets from the starting point, the length will be really short. So the length of this point will be 0, I guess, because it's the tip of the point, and by this calculations. And the points which is all on close to the starting point will be the length between the last point till the current point. So what I was explaining, it was a bit wrong here. the attribute length for the point is if this is the branch, and if there's a points in between on the branch, the length of this one will be 0. The length of this one or this one will be similar to this value. And for this one, it's this value. Because this is what it's doing inside the code. I was a bit mistaken about this one. Sorry for that. Okay, so after I got the lengths, let's do the sub branch finally. Okay. I'm gonna use another wrangle. I'm gonna call this fork, and which will be a primitive wrangle because I wanna do for each main branches. So primitive wrangle, and I would like to set the filter when the generation is equal to 0. And do I have a generation here with the primitive? Nope. Let's go back and let's go to the initial primitive. Oh yeah, here. I'm not gonna set the attributes as a gen, but I'm gonna set as a group. So set prim group called gen at prim num to 0. Right. Let's go back and reset the solver here so that I could search for the gen here. Maybe not. Let's go restart, go back, and still I don't seem to have a. Okay, let's go to the primitive. If I have, nope, I don't seem to have it. Okay, initial primitive. At this point, I still haven't done. Still, I don't have it. I guess it's because this is 0. What if I set to 1? No. I guess it's because there's no primitives generated initially. I must have been unable to apply the group. So I'll just go with the integer attributes in that case. Because in that case I should be able to have it. If I look at the primitive, yes, I have a gen. Okay. Now, then I will say if the gen equals to 0, which means it's a main branch. Now let's write some code here. This will be pretty long. First thing I would like to do is to make get the points from the primitives, each primitive. So int npts equals to prim vertex count at prim num, and for int 0 npts npt equals to vertex point, vertex index prim num I. Maybe this could be done using more simply, like using point prim points or something. Well, maybe it's dependent on maybe it's better to use the vertex because it's in the order, so I'll just go with this. And int fork, get the fork attributes from the points. Initially the main branch should have 0 sub branch, so this should be 0 from the main points, the main branch points. And also let's get the source attributes from the points, whether it's started from, whether the points on the starting position or not. Okay, and make a condition here. If fork is 0, which means there's no sub branch at this point, plus and source is 0, which means the point that sub branch is gonna be made is not on the initial starting point. Alright, so in that case, vector pos will be a point position at npt, and vector axis is a normal vectors at the point position, and the direction could be get like this. Okay, spell mistake. Apply, seems okay. Okay, now so in Anton Grabowski's original tutorial, he's making 4 types of sub branches, so I'm just gonna follow that. So basically what I'm gonna write here is pretty much the same, so you can copy paste from his code if you would like to. First of all, it's choice. So the choice, the integer choice, will be the type of the sub branch. It goes from 0 to 3, so you have 4 types of branches. And make a condition with the random. So randomly create a sub branch out of 4 choices, out of 4 types. So let's make a random value before making the condition. Rand using the ptnum plus probably a seed number. So float seed chf seed and seed, which will be from 0 to 1. Now here comes the condition. If the random is 0.2 larger than 0.25, or let's say less than 0.25, then let's make it simple. Choice will be 0. If random is larger than 0.25 and less than 0.5, then choice will be 1. If random is larger than 0.5 and random less than 0.75, choice will be 2 if random is larger than 0.775, then choice will be 3. So for those numbers, I guess I could also parameterize it in order to define how much of a types you should have, how, like, if you want to control the amount of types to get, maybe you can control those numbers as well. Should I do that? Okay, I'll do that. Land 1. What's the correct name for this one? Range 1 CHF, range 1 float, range 2 range 2 float, range 3 right, and replace those with the range 1. And this will be range 2. Oops. Range 1. This will be range 2. This will be range 2. Range 3. Range 3. Okay, apply. Let's promote those parameters. Okay, so the first one, seed, could be any number. The range 1 could be 0.25, range 2 0.5, range 3 0.75. Alright. Okay, so here comes the branch generation function. If the choice is 0, let's set the color to be red. If choice 1 and the choice 0 will be the left side branch, the choice 1 will be the right side branch, and the color will be green. Okay. If the choice equals to 2, then the color should be, it doesn't have to be, but blue. And then if the choice is equals to 3, then the color be yellow. Alright, now in here I would like to call the function in order to generate the starting branch of the sub-branch. So initial branch. So for that one, I'm gonna make a function on top of here called and void fork, using some parameters like position, axis, direction, color, as well as the integer's choice, primitive number, and the point number. Right. Okay. Okay. What I'm gonna write here is the function in order to create the initial branch. Now, first thing first, step, which will be the step lengths of the branch, and as for the main branch, I have already set the step on the new controller before, so I'm gonna just use that. Let's promote these. And for the steps, let's go back to the GL1, copy the branch step parameter, and then go back and paste it here. Right. Okay, another one. Float ang x. This will be some value in order to use it for modify the angle of the sub-branch. I'm gonna name this ang x float pt off angle. This is the offset angle based on the point position. In order to make the angle of the sub-branch more randomized based on the point position and the primitive number. So I also want the prim of angle which will be prim of angle, and finally float seed. Now let's all promote these parameters and let's see what parameter could be promoted globally. So for the angle exp, I'll just set 0.7, and for the pt offset angle, I would like to set it as a degrees. I'll set to 15. So based on the point position, there's a offset of 15, maximum 15 degrees. For the primitive angle, I would like to set it to 60. So maximum of 60 degrees offset will be applied based on the primitive position. And for this one and this one, PT offset and PT prim offset, I think I can promote it globally. So go back to the controller, then let's add that number here. Okay, so sub branch PT offset, sub branch PT offset. Yeah, I gotta say angle. Okay, and the range could be from 0 to 90 degrees. And let's add another one, sub branch. Let's just delete the space in between the sub and branch. Sub branch prim offset ang, sub branch prim offset ang. The range from 0 to 90 degrees, apply. Alright, And for the PD offset 15, prim offset 60, and let's copy this parameter, go back to the solver and paste it on here. Okay, paste it here as well and rename this to prim offset angle. Okay, let's go back to the code. And where was I? So now I have those variables. I need to use those in order to set the initial subbranch. Before doing it, I would like to convert this PT offset angles and prim offset angle to a scale value. So float scale prim equals power and prim num with the ang x with prim off angle. So by doing this, you'll have random angle based on the primitive number together with the ang x to have an angle between 0 to, in this case, 60. Same for the point, scale point. Let me just use the fit for this one. Fit 01 rand and PT to -1 to 1 multiply by PT off angle. Okay. Now, since for the sub branch, for the main branch, you will have, based on the main branch, you will have 2 sub branch on each point like this, basically. As a leaf. So I'm gonna make a for loop to iterate just 2. And here comes a bit complex conditions here. First of all, let's make a side multiple variable. Start from 0, and if I equals to 0, which in this case I would say this is the left side, and will be side mult will be 1. Else, if it's on the right side, side mult will be -1. And I'm gonna use this variable later on in order to calculate the flipped angle. Okay, so next let's make a matrix rot in order to use this for the rotation, in order to make it as a rotation matrix, and make an angle here based on the scale prim and scale point which I made using those random value with the maximum offset angle for both point and primitive. So the angle will be radians 90 degrees plus. It's 90 degrees because since what I'm gonna rotate is the direction on the current point, and the direction is on is heading to the main branch. So by rotating into 90 degrees, it will create a rotation angle like this if it's 90 degrees. So that's why I'm writing 90 degrees plus scale point and scale prim to offset the angle. Okay. Now here comes some conditions for each choices, like how should the angle be modified. Now, the first condition, if the choice is not 2, which 2 is both sides. The 3 is symmetrical. So, I mean, the 3 is also both sides, but the branch is symmetrical, like this one, like here. So the branch direction is both heading to the same direction. But for the both side, what I mean by both side is that if one side is going this way, then the other side will go this way. One side is go this way, and one side will go this way. Like that. Something like that. And if it's on just on the left side, you will have only the left sub branches. On the right side, you will have just initial branches. And if it's on the right side, then you will have the branch just on the right side, and on the left side you will have just initial branches, sub branches. And that's all for types 1, 2, 3, 0, 1, 2, and 3. Okay. Now, where was I? Go back to the fork. And if the choice is not 2, which means the choice is not both sides, which means if it's either on the left side or on the right side on the symmetrical, then multiply the angle, the base angle, by side mult. So the side mult is defined based on the side of the branch, either it's on the left side or on the right side. Okay. So if it's on the left side, the side mult will be 1, and the right side, the side mult will be -1. So that's the first modification for the angle. And else if the choice is 2, or I could just else if here comes another random value, since for the both side, for this one, this could go right here, or could be this direction as well. So it could be either way. The right side will be higher, on the left side will be higher. So that's 50%, 50-50 chances for that. So let's make random in order to make a condition. So rand based on the primitive number plus some random number plus seed is less than 5, then add the angle by 180 degrees. Times I. So if it's on the left side, this will be 0. If it's on the right side, this will be pi. Yeah. That's it. Okay, and I think this is correct. I hope this is correct. I think, oh no, this is not wrong. This is not correct. Sorry. The condition is okay if the angle, if the 50% chances, I will multiply the angle by -1. Just flip. Okay, it's good. Now, another condition. If the choice is equal to 1, which means on the right side, then set the angle, also flip the angle by multiplying by -1. Else, if the choice is equal to 2, which means both sides, then add angle by pi times I in order to create something like this. I'm just creating this angle and this angle. So there's two sub-branches with different angle, but if you look from far away, it looks like a single straight line. Well, okay. Now I got the angle. I'm gonna rotate the matrix using the rotate with the angle, with the axis. Okay. Now let's set the new position for the new point. So vector and pos on the current position plus the direction times rotation, which will define the rotated direction times step in so that you could set the size of the step. Okay, now using that, let's make initial sub branches. So for that, first let's make a prim using add prim with the polyline and pt0 equals to add point pt1 add point step no wait a minute. New position, correct, yeah. And I guess I don't need to add new point here, probably, because I already have it here. This should be the starting point. So instead of adding new point for the pt0, I could just say npt, I think. Let's try. And add vertex for the primitive with pt0, add vertex 0 prim pt1. Okay, let's just set some primitives. First, set prim iterative with the name generation Now the generation 0 was the main branch, so the generation 1 will be the sub branch. Now another one, set prim attrib, which will be the parent attribute integers. This could be the npt, which will be the parent point number. I thought it will be a primitive number, but actually it's a point number, so npt. Okay, and set prim attrib side for the side it's either 0 1, and I could just use the I on the for loop. And set prim attrib for the color, I'm just gonna use color from the input. And then set prim attrib type, like what type of sub branches gonna use the choice plus 1. So if it's choice 0, then it will be 1. If it's choice 3, it will be 4, because choice 0 is the main branch. I mean the type 0 is the main branch. Okay, next. I have set this type. Let's also set the set point attrib with the n normal for the ptn, which will be axis, and set point attrib with for the direction at pt0. Actually, I don't think I need to do this thing because it's already being set on the point position, but anyway I'll do it. Direction times rotation. Okay, that's the new direction. And set point attrib for pt1. This could be axis, or I could also refer to using the ref points, but right now I don't really seem to, I'm not connecting the ref points here, so, and it's gonna be too much long code, so I'm just gonna use axis for that. It shouldn't be that different. And set point attrib 0 dir pt1 dir times rot. So basically the same as this one, pt0. Maybe let's well, let me keep like this and see how it goes. And finally, final condition, if the choice is larger than 1, or which means larger than 1 means either both sides or symmetrical type, or choice is less than 2, which means left or right side, and I equals to 0, then set point attrib in that case that will be the end point position endpoint of the sub branch, where it should where it is the endpoint of the sub branch and where it should start the next growth. So set 0f and this will be the sub branch end pt1 to 1. Okay. The reason why I have this branch is because for the left or the right, I only want one initial branch, and for the other side, I'm okay to have a f end to be 1, but for the other one, f end should be 0, and nothing's gonna be grown from this f end equals 0. Okay. And from what I remember, maybe the f end is set as a group. Let's check that out. F end is, yeah, indeed, it's in groups, so I have to set it as a group inside here. So set point group fn pt1. Okay, that's it. I think that's good for the initial sub branch. Let's try that out if I got it. Let's enable this one. Just reset here and here, go back, and let's play. Okay, it kind of started, but no, it's not making any branches, obviously, sub branches, obviously, so something must be wrong. Let's see what's wrong. Okay. Now, this should be related to this one. This should be related to this one. Maybe this is the point which was wrong, so I'll write like this. Okay, go back. Nope, still nope. Still no. Okay, let's see. I'll just pause a little bit and see what's wrong. Okay, obviously I found where it's wrong with this, because the reason is because I have made this fork functions, but I haven't called it yet here. Yeah, that's stupid. Okay. So let's go down, and inside conditions for each choices, let's call the fork and actually create the sub branches. So for the first one, pause, axis, dir, color, choice, prim, and pt. And actually, I don't have to write it here, but I could write it outside the condition and make an initial color condition like vector color 111, and by using the condition change that color. Okay, like this, and this should give you the condition I want, possibly. Now apply, accept, close, oops, enable the array, and then go back and play. Yeah, so right now it's just the initial sub branch, but it is indeed creating at each main branch And that's good. That's good. Yeah. Let me look at the initial scatter points. And their starting point. Seems like I have many points here, which might not be a good idea. Let's check that out, because okay, let's give another mark called source. With the text is fine. Let's color this red. And hide these. I don't need a direction. I only need a source. Now, am I missing the source? Yeah. Right, the source is on the group right now. And the fork is as well. And what I did wrong is that I get the condition as an attribute. Right. So where I did wrong is around here or here. Okay, so not this one, maybe this one. Okay, so yeah, this is the condition I got wrong. I'm getting an attribute like this, but actually what I want is the group, whether the point has the group or not. So let's do, for that, I could use int fork equal in point group. Was that the correct spell? In point group, okay. And fork at npt and source in point group 0 source npt. All right, and delete those. Oops. And this should go well, so that I could delete the branches on the starting point, the sub branch on the starting point. Hopefully. Go back. Yeah. Now it's deleted. Now it's more clear. Okay, now I have the initial sub branch. What I need to do is, as well as I did for the main branch, I have to make it grow. I'll name this fork, and the next thing I would do is the growth for those fork sub branch. So I'm gonna make another wrangle. In this case, a point wrangle. And I'm gonna filter it. I'm gonna name it first with the sub branch growth, and filter it with the f end, since this is the end point of the sub branch, like here or here. Okay, getting tired. First of all, let's make a variable. Float step, this again, step. I'm gonna copy it from the controller later on. Float angle, CHF angle. Is this the base angle for how the sub-branch should grow? And float max length, the maximum length of the sub-branch, and this will be the ratio that will be from 0 to 1 in order to make a comparison between the main branch lengths and the sub-branch lengths. So the sub-branch length should not be over main branch lengths. Okay, and seed. Right, and here, since this is the another growth, as I did for the main branch, I want to check the collision here. Well, this is really tight. This, it seems like it's been built from the same point position. Let me check that out. This doesn't look correct. Oh well, it looks okay now. Okay. So in order to calculate the intersection or collisions, I will do the same as I did for the base, the main branch growth. So for the second input, I will connect the reference point again here, and then for the third input, I will input the collision geometry, which will be calculated the same as for the main branch. So I'm just gonna copy this one, paste it, and bring it up here, up around here, connect it here, which will make a collision plane geometry like this, and connect it to the third input here. Good. Now let's do the collision detection. As I did for the main branch, first I'll make an empty variable vector and make an array. Use an intersect from the second input, the third input, from point position with plus the direction times step by 0.1 and the length of the direction. It will be, the array will be VR at marked directions times step by 3. It's the same for the main branch, and I'll be on LV. Okay, now if the array is equal to -1, which means there's no collisions, which means you can grow, you can continue grow. First thing I would like to get is the parent point number from the primitive. So int parent equals prim parent at prim num. So at prim num inside a point wrangle will give you the primitive number for the which point is consisted on. Okay, and this will give you the parent point number. Then after that, let's get the float parent lengths. So each point has lengths. So I could get the lengths at the parent point like this. And I could also get the lengths for the primitive, which is the sub branches lengths. Like this. Now here comes where I would like to compare the parent point lengths together with the max lengths. I mean the sub branch lengths. So if I look at where I've set the parent, I think it was something around here. Let me check. Yeah, so this is where I set the parent, and the parent is set as NPT, and NPT is from this input on the fork and here, and NPT comes from the vertex point on the primitive. Alright, so it's more like previous point on top of the curve, on top of the primitive, I mean the sub branch. So inside here, what I'm making as a condition is like this: if the length, which is from the primitive, the current sub branch primitive length is parent length times max length is less than parent length times max length, then add the branch. So okay, I've been looking into this conditions, why it is, but honestly speaking, I couldn't really get why the condition is like this, because it still works like this, like lengths larger than parent lengths times multiple max lengths. I know it's a condition to reduce the length of the sub branch, and somehow it's comparing the lengths with the parent lengths, and I think I might not be getting the correct image what the parent length means. Basically it should mean that the length itself is from the primitive, so the length of this branch, and the parent length is the length which is on the previous point of the current point, which should be this one for the initial point. So for this point, the distance, the parent length distance is like from here to the end point, and it's comparing this length multiplied by max length with this length, with this whole length. But in this case, this hasn't been born yet, so this doesn't have a information, how much how far is it or how long is it. So definitely you'll get the next branch, but for the next branch, yeah, maybe it's doing the same conditional stuff. I'm just using this condition right from the Anton's tutorial, so if you want to get in detail, you should look at his video. Although it's in Russian, so I couldn't understand, unfortunately. And first I'm gonna make a random angle using the base angle, which is from the promoted parameters. Oops. And use the fit 01 with the random, like prim num plus seed to convert it into -1 to 1. Okay. Okay, first let's set some value here. Angle, I mean the step I could just copy from the controller, so let's go here and copy the step angle. Where is, okay, this one, copy this, go back, paste it here. Okay, the angle is the, like how drastically the sub branch should change for each iteration. So it doesn't have to be really big, because if it's too big it will like call. So like 2 degrees or something, it'll be fine. And for the step, if it's same as this main branch, it might be too long, so I will multiply this by 0.5 here. Okay, and this could also be a speed, could be 1. I'll try with the 1 first. And the max lengths, this is the ratio of the lengths. So I'll just go with the 0.75 and the seed randomly applied. And I don't think I need to promote any of those parameters globally, so I'm just gonna leave it as it is. And let's continue with the code. Okay, so I have made the angle, the random angle. Next thing, let's get the side information from the primitive. Whether its branch is on the left side or on the right side. Okay, let's go to the geometry spreadsheet. If the primitive have the side, okay. Yeah, it does have, so it's okay. Now, if the side equals to 1, which means on the right side, then the random angle I'll multiply by -1 so that it flips, the angle flips. And make a matrix, rotation matrix. As an ident first, and rotate the rotation matrix with random angle with normal axis. Okay, the next direction will be the current direction times rotation, which will rotate the vector, and the vector and pos, which will be the next position, will be the current position, plus and direction time step. Okay, and add a point to the next position, add point to end pos, right? And also get the prim number from point prims, at prim number, oh no, I mean the PT number, and just get the first one, and at the vertex to prim with the point, added point. Okay, and for this new point, set the primitive, set the group and attributes. First of all, set point group fend pt to 1, and set point attrib 0 n pt normal vector, and set point attrib direction with the new direction. And finally set point attrib, set point group to the f end of current point to 0, because I have just made a new point for the tip of the branch, as a tip of the branch, sub-branch. Now apply, I don't get any errors, hopefully. Nope. Accept. Now let's see how it goes. Let's go back to the geom, hide the points, and go do the calculations. And yeah, I think it's going, but something is a bit wrong here, obviously. Yeah, especially right here, it's pretty weird what's happening here. Yeah, I don't think it's correct at this moment. Let's see where's wrong with this. Yeah, as a graphic it's fine, but as a frost it's totally not okay. It's totally not okay. Okay, let's see. Oh yeah, one thing I was missing is that since I'm comparing the primitive lengths, and I haven't set any primitive lengths yet, so let's set it. Measure. I'm gonna use the measure node and get the parameter and override the name with lengths. Okay, let's do that again. Go back. Still something is wrong. Yeah, something's totally wrong here. Let's go back. I am going to pause this a bit to see where it's wrong. Okay, I think I know where was wrong. I seem to have several sub-branches here. That is because after I created the sub-branch, I haven't set any flags for the main point, the points on the main branch, that you shouldn't have any more sub-branch from the already used points. And that flag is the fork, which is set on this one, fork. And see that there's a condition somewhere, yeah, here. If the fork is 0, then create the point. But then I haven't set it to 1 after creating the sub branches, so it's always 0. It keeps going with 0, so it keeps creating a new branch from this point. So that was the problem. So for the end of around here, let's set point, set point group to the name fork at npt with 1. Now hopefully this will do the job. Let's go back with the array displayed on reverse, and let's see. And yes, I think it went well, pretty well. I guess I am missing some more variable because the angle is pretty much 90 degrees based on the main branch, so I think I forgot to promote some of the angle, I think. Let's check that out. For this one, if I click here, looks fine. This one, if I click here, it's still fine, I guess. But basically this should be the place where it controls the angles. And it's, oh yeah, this is 0. That's the problem. Now let's go back. Controller. Okay. Doesn't seem to be linked. So I'll just copy this parameter. Go back here. Paste relative reference. I'll just delete all. Ooh. Delete channel and then paste relative reference, which will give me 60. Okay. Now let's do the generation again. Yeah. It looks more natural. The angle looks more natural. Well, this is a bit exaggerated, but looks pretty good. Looks pretty good. I mean, it's still pretty straight from what I see. Well, it does make in a curve a little bit. Yeah, let me check with the growth calculations where it controls the angles. So I have those step angle max lengths, and here I am rotating the angle with and this one, and let me just debug by making this angle a bit bigger, like 15. So for that, it should give a really exaggerated curve. Let's do that. Okay. Play. Yeah, it does curving, so it does working. Now I'll just make it back to 2. I guess I would just need to reduce the size of the step for the step length for the sub branch, so that it'll be more high res compared to the main branch. So I'll just multiply by 0.5, and that seems more natural, I think. Yeah, look much better. Look much better. Looking much better. Okay, okay, okay. Maybe I could also make a parameter for this. I guess I'll go with this. I'll just make it 0.4 just to make it more high res. And finally, since this is just a curve right now, I also wanted to make it as a 3D geometry, like using poly wires. So in order to use that, I have to set some p-scale for the scale on each point. So I'm gonna make a point wrangle after the measures and name this p-scale, and apply piece p-scale by 1 at increment by 0.1, and let's reduce the clump and the p-scale to be 1 by setting the filter piece. If the p-scale is less than 1, then add those. So the p-scale will be stopped at 1, the maximum will be 1, the minimum will be 0 or 0.1. Alright, now after that, that's not enough for the p-scale. I also have to do some modifications for the p-scale based on the lengths on each point, the length attributes on each point. So let's do that. Okay, make a point wrangle again outside the solver, connect to the solver, then p-scale, and this is how it goes. This is also based on the Anton's algorithm. I'm just gonna use the same one. p-scale. Okay, it's getting slow. I'm just gonna save this. Equal times equal pow fit lengths of the points and from 0 to 1 and 0.1 to 1 and ch. I need to give a channel for this one. I think I'm just gonna give a 1, so I don't need to use a power after all. Maybe I could use the as a variable chf xp and at p-scale times equal fit 01 rand ptnum from 2.9 to 1.0, which will kind of randomize the scale a bit. Then p-scale equal clamp p-scale by 0 and 1, or 0.5 or something. Okay, let's see how it looks like with the poly wire with this p-scale. Okay, let's play a little bit. Okay, and connect a poly wire. And the divisions 4 is fine, and the segment's fine. Okay, I need to use the P scale for the radius of the poly wire, so I'm gonna use the expression here, point OP input and PT P scale 0 times something like 0.1. Yeah, looks okay. I don't see any shadows right now, so let's attach the normal to see how it looks like. Okay, now it looks a bit weird on this, like here, so I guess the calculation is not enough. Oh, I see why, because the AXP is right now 0, so I have to make it be 1. Oh yeah. Now this looks more like a frost. Now the base might be too thing I could increase by multiplying here, so I could parameterize this one as well. So let's go here and make a parameter thickness, which goes from 0 to 1, apply 0.5, copy parameter, and I'll paste relative reference here. That's good. Now if I could change the parameter here, I could control the base thickness of the frost. Yeah, that's it. Frost. Okay. Now it's mostly over. I mean, what else I need to do? Let's just set the color for this frost. Maybe for this one is white is okay. For the sphere, let's assume this is a bubble. Blue bubble, something like a light blue bubble. Oops, no. Okay. And wait, merge together. And I also need a normal for the bubble, I guess. Yes, let's make it darker. Great. So here it is, a frost solver. Let's start playing it. I'm gonna pause and skip to where it caches all the frames. Alright, let's see the results. Okay, let's play. Yeah, looks really like a frost. Still slow. Well, so yeah, this is it. This is how I implemented the Anton's 2D frost solver into 3D capable frost solver. And basically it's pretty much the same for the core function, core algorithm. I just tweaked some of the calculations so that I can use it for the 3D, and also I have removed some of the code as well to make it more simple, although it took like 3 hours to explain. Yeah, it was a long trip. Okay, thank you for watching it. I hope you learned something. Thank you.